All right, welcome back. Today I'm going to go over the 9.3 identifying limited and excess reactants with mass. Formerly we were doing moles, but now with mass we're going to be adding a few more conversion factors. In fact, usually 3 conversion factors. But we are still identifying limited and excess reactants, but we're just looking at mass instead of just, moles. So I'm going to use method 1 throughout this assignment because of space, and you can, method 1 is probably the best the best method. So remember method 1, you pick a reactant, you convert it to the other reactant, and you compare the values of your given with what you need to figure out if it's an excess or limited. So I'm just going to start with zinc. So I have 130.7 grams of zinc, and I want to get to this sulfide here. Okay, sulfur 8. Okay, so I'm in zinc, and I can't go straight to moles because I'm in grams. So I have to convert grams to moles. And how you do that is to divide by the molar mass of zinc. And if I look at the periodic table, the molar mass of zinc is 65.37. Right? So I'm going to round. 65.38 grams of zinc is equivalent to 1 mole of zinc. So now I'm in moles of zinc, and I can go from moles of zinc to moles of sulfur. So when I look at the equation, the ratio is going to be 8 moles of zinc to 1 mole of sulfur. So I'm in moles of zinc. That means moles of zinc will go down here, but it's going to be 8. Oops. That's S at 8. Wow. And I'm going to, okay, I really just epically messed up there. All right, let's try that again. Okay, so it's supposed to be 8 moles of zinc to 1 mole of sulfur. All right, but I don't want moles of sulfur. I gotta get to grams so I can compare it here. So 1 mole of S8, I need to figure out the molar mass of S8. So to figure out the molar mass of S8, I got to do a little bit of math. So I have sulfur, and I have 8 of them, each at 32.06. So the molar mass of S8 is like 256.4 grams, I think. So that goes here. All right. So now I can just punch this into my calculator and figure out how many grams of sulfur I have and compare it to what I was given. So 130.7 divided by 65.38 times 1 divided by 8 times 256.4 gives me around 64 grams of S8. Now, this is what I need. This is what I was given. So I was given more than I need, so therefore S8 is my excess, and zinc is my limiting. How many grams of excess reactant remain? So I'm given 256.5 grams of sulfur. So I'm going to take my given minus my need. So some simple algebra here. I get 192.5 grams of sulfur remain. How many grams of the product are formed? Now remember, with the product, you have to start with your limiting. And our product, if I go back to the equation, is zinc sulfide. So I'm going to start with zinc because that's my LR, my limiting reactant, and I'm going to go to zinc sulfide. So let's divide this out a little way. All right, so you start with what you're given. In this case, your limited reactant, 130.7 grams of zinc. And I'm going to use the same conversion of going from zinc mass of zinc to moles of zinc. So the molar mass of zinc was 65.38 grams. That's equivalent to 1 mole of zinc. Now I'm in moles of zinc, and I have to use the mole ratio to go from zinc to zinc sulfide, and it looks to be an 8:8 ratio. So 8 moles of zinc go down here, 8 moles of zinc sulfide go up here. My final conversion is figuring out if I have a mole of zinc sulfide, how many grams is that? So I'll squeeze it. We'll squeeze it right here. Zinc. I have one of them at, let's see, zinc. Periodic table, 65.38. And sulfur, I have one of them at 32.06. And I'm going to add them up. And I get the molar mass of like 97.44, I think. I hope. So. All right, now I'll punch this into my calculator. 137.7 times 1 divided by 65.38 times 8 divided by 8 times 97.44 divided by 1 gives me 194.8 grams of zinc sulfide. So that's how much product can be made with our limiting reactant zinc. So there's problem 1. Moving on to problem 2. Carbon reacts with steam at high temperatures to produce hydrogen and carbon monoxide. Hydrogen can't exist by itself, so it's going to be hydrogen gas. And I know it doesn't say hydrogen gas, but it should on your worksheet. I think I made the correction. But first off, I need to create a chemical equation just to make sure that it's balanced. Okay, so this is a word equation. I got to put it into a chemical equation. Carbon reacts with steam, which is H2O. So it's going to be carbon plus H2O. And it says produces hydrogen and carbon. Is this balanced? Wait, carbon monoxide, my bad. Word wrapped around here. Yes, this is balanced. Okay, cool. So everything's a 1-to-1 ratio, which is nice. So, first question. If 28.8 grams of carbon is exposed to 55.8 grams of steam, identify the limiting reactant. So I'm going to use method 1. I'm just going to pick a reactant, get to the other reactant, or convert it to the other reactant, and compare the given with what I'm needed. Or what, yeah. So, start with 28.8 grams of carbon, because why not? It's listed first. So, 28.8 grams of carbon. I need to go from grams of carbon to mole of carbon. Molar mass of carbon, look on the periodic table, 12.01. I'm in moles of carbon. I want to get to water or steam, and it's a 1-to-1 ratio, which is nice. So 1 mole of C goes down here so it can cancel out, and 1 mole of H2O goes here. Now for my final conversion, I have to go from moles of water to grams of water. So to do that, I have to multiply by the molar mass. Molar mass of water, I'll stick it over here. So I have hydrogen 2 at 1.01 and oxygen at 1 with 15.99. And it gives me 18.01 grams per mole. So 18.01 grams of water is equivalent to 1 mole. Punch this in my calculator. 28.8 times 1 divided by 12.01 times 1 divided by 1 times 18.01 divided by 1 gives me 43.2 grams of H2O. This is what I need. I go back to my original problem. This is what I was given. So in this case, I was given more than what I needed. So H2O is excess. while C is my limited. So, yeah. How many moles of each product are formed? Okay, so whenever you want to figure out the actual product, you have to use your limiting, because your limited, depends or limits how much you can make, right? So I have to start with carbon. 28.8 grams of carbon, and I want to get to each product. Okay, so I'm going to have to set up two stoichiometric equations. All right, one that goes to hydrogen gas and the other one that goes to carbon monoxide. So to go from grams of carbon to moles of carbon, I divide by the molar mass of carbon. And then moles of carbon, and let's go to hydrogen gas first. So everything's a 1-to-1 ratio. 1 mole of C to 1 mole of H2. And then to go from a mole of H2 to grams of H2, I got to figure out the molar mass. Well, hydrogen is 1.02, but I have 2 of them. So the molar mass of hydrogen gas is 2.02. All right, there's my first one. Oh, stop. I didn't have to do that last conversion because they said how many moles. I'm jumping ahead of myself here. Oop. Okay, go back. They want moles. All right, so set up our second equation here. 28.8 grams of carbon. Same conversion. I got to get to moles of carbon by dividing by the molar mass of carbon. And it's going to be a 1-to-1 ratio. 1 mole of C to 1 mole of carbon monoxide. Okay, so I'm going to punch this into my calculator. And the answer should be the same. You should get 2.40 moles of hydrogen gas and 2.40 moles of carbon monoxide. Now down here it says what mass of each product is formed. So I'm just going to go from moles to grams. I have 2.40 moles of hydrogen gas. Well, to get to grams, you multiply by the molar mass. So I put 1 mole of hydrogen down here. The molar mass of H2, as I explained earlier, was 2.02 grams. And I get approximately like 4.8 grams of hydrogen gas. Now, for carbon monoxide, I have 2.4 moles of CO. To go from moles of CO, I got to multiply by the molar mass of CO. So carbon is 12.01, and I have to add that to 15.99, and I get around 28 grams as my molar mass. So 2.4 times 28 divided by 1, I get 67.2 grams of carbon monoxide. So there are my 2 answers down there. These are my answers for this one. And this was my answer for 2A. All right, like I've said before, I really hope this was helpful. And remember, if you're struggling, to reach out. Thanks.